to inhibit corrosion in boilers and their connecting steam and water systems, to inhibit stress corrosion cracking, and finally to maintain high steam purity by control of boiler water carryover. The use of a proper boiler water treatment program will benefit the cleaner by reducing fuel consumption, reducing maintenance of the boiler and the distribution system, having fewer outages and disruptions of operations, also by increasing safety, reducing water and chemical costs, and extending equipment life. Now let's look at some problems that can occur in boilers that are lacking an effective treatment program. The first problem we're going to look at is boiler scale. Boiler scale is caused by impurities being precipitated out of the water directly onto the heat transfer surfaces, or it can be caused by suspended matter in the water settling out on the metal and becoming hard and adherent. Common feed water contaminants that can form scale include calcium and magnesium salts, iron, aluminum, and silica, as well as many others. These contaminants are less soluble in hot water than in cold, which causes them to precipitate out. In untreated systems, these precipitates then deposit onto the surfaces in the boiler. This will interfere with heat transfer, reducing efficiency and increasing fuel and operating costs. These deposits may also lead to hot spots, which can cause local overheating. To help you understand how much a boiler's efficiency is affected by scale formation, note that just a 1/16 inch deposit of scale on the water side of the boiler's heat transfer surface relates to a 15% energy loss, and a 1/4 inch thickness of scale results in an almost 40% energy loss. Here is a picture of two different types of boiler scale. The different colors come from the different minerals that are in there. On the left, you probably have calcium or magnesium. On the right, iron and that type of material. Remember too that softened water can cause problems such as the formation of hard silicate scale. Unsoftened feed water contains calcium, which will produce a soft scale and sludge in a properly treated boiler. And this soft sludge carries down the hard scale formers like the silicates that are naturally present in water supplies. Water softeners remove this calcium from the water, and with no soft sludge, the hard scale can form on tubes more easily. Another common problem associated with the lack of a proper boiler water treatment program is oxygen pitting. Dissolved oxygen results in the most destructive form of corrosion that affects the water side of boiler tubes. Even in very small concentrations, oxygen is highly corrosive when present in hot water. Iron oxide generated by the corrosion can also form iron deposits in the boiler. Oxygen pitting may be very localized in a small area, or it may cover an extensive area in the boiler. One situation I always like to note is that in new boilers, or in one which has been drained and refilled with untreated water, air bubbles will form on the tubes. In a very short time, pits develop under these bubbles. Penetration as high as 50% of the tube wall has been known to take place in one stagnant period of 2 weeks. So once these pits form, they proceed rapidly even under operating conditions. Acid corrosion is another type of corrosion that can occur in the boiler. An acid attack occurs when the pH of the boiler water is too low. Below a pH of about 5.5, the water is sufficiently acid to dissolve steel, and under these conditions no pits form. Instead, the corrosion is relatively uniform and the steel gradually gets thinner until it is too weak to hold the pressure, or a small hole develops. Caustic corrosion is the next type I would like to talk about, and it develops when scale deposits of a porous nature allow boiler water to permeate them, causing a continuous buildup of boiler water solids between the metal and the deposits. This caustic concentration in these trapped areas can reach extremely high levels, even up to 10,000 parts per million or more. This caustic solution dissolves the metal, and it usually occurs in irregular patterns. It's often referred to as caustic gouging. Alkaline stress cracking, which is also known as caustic embrittlement, that is a form of stress corrosion resulting in the intercrystalline cracking of steel. Caustic embrittlement occurs when all of the following are present. You have to have specific conditions of metal stress, a mechanism for concentration such as leakage, and excess alkalinity in the water. Boiler tubes usually fail from caustic embrittlement at the rolled tube ends in modern boilers. Please also note that the use of softened water can lead to levels of excess alkalinity in the boiler, increasing the likelihood of this problem. Note on this picture that's coming up the intercrystalline cracking. It's very identifiable when a boiler is inspected after this type of corrosion occurs. Corrosion can also occur in the steam and condensate lines. One type of corrosion found in these areas is carbon dioxide corrosion. Upon heating the boiler water, carbon dioxide is formed. This carbon dioxide goes with the steam and it's dissolved in the return condensate. Carbonic acid is then formed and this leads to acidic corrosion. Also remember that oxygen has many opportunities to enter a condensate system as well and can cause oxygen pitting in this area just as it can in the boiler. Another type of corrosion in this area is copper complexing corrosion. And this is usually caused by ammonia, which is the most common agent found in the boiler water system. This can be present in low concentrations due to the decomposition of organic contaminants, hydrazine or amine type treatment chemicals. Boiler water carryover is another significant problem that occurs when the proper boiler water treatment program is not provided. Boiler water carryover is usually caused by excessive levels of dissolved solids, suspended solids, and or alkalinity in the boiler water, which lead to foaming. And this foaming in turn causes droplets of boiler water to escape with the steam. Priming also leads to carryover when slugs of water are thrown over the steam. This is often caused by an excessive steam demand or a rapid increase in load. Using softened water in the boiler can cause a buildup of excess dissolved solids as well as the excess alkalinity we've talked about already, and both of these can lead to boiler water carryover. The effects of carryover can be very serious. Steam becomes contaminated, water hammer may occur, slugs of boiler water can damage machinery down the line, and dissolved or suspended solids in the boiler water will deposit in the steam and condensate system. Now let's look at how an effective boiler water treatment program can provide protection from all of these possible problems. Boiler water treatment should help to prevent boiler scale in several ways. First, the treatment should contain hardness precipitators. These will pull the hardness minerals out of the boiler's feed water. It should also contain ingredients which disperse these precipitated compounds that will form a sludge, and that should be easily removed with an adequate blowdown procedure. The boiler water treatment should also prevent scale formation by keeping the boiler's pH and phosphate concentration within desired ranges. Without any scale formation, caustic gouging is much less likely to occur also. In order to prevent corrosion in the boiler and in the connecting steam and water systems, the boiler water treatment should contain oxygen scavengers. These compounds will remove the dissolved oxygen from the boiler's feed water, preventing oxygen pitting. The treatment should also control the pH of the boiler water and maintain the optimum range of alkalinity. This prevents both acid corrosion and alkaline stress cracking in the boiler. Boiler water treatment should also have neutralizing amines. These will go with the steam and provide protection against corrosion in the boiler head space as well as in the steam and condensate lines. It's very important to remember that all of these benefits depend not only on the proper usage of boiler treatment products, but also on an adequate blowdown procedure. After the boiler treatment precipitates the hardness and impurities from the boiler water, this unwanted material must be removed daily by blowing down the boiler. Remember also that the blowdown is most effective if done early in the morning before the steam gauge climbs above about 15 to 20 pounds per square inch. And this allows the solids that settled to the bottom of the boiler overnight to be removed with a fairly small quantity of blowdown. In the end, proper boiler water treatment and regular boiler maintenance will not only protect the investment the cleaner has in their boiler, but it will pay for itself in minimizing operating costs. These are the 3 boiler water treatment products produced by ADCO: ADCO's Boiler Compound, Laidlaw's Boiler Guard, and ADCO's Boil Soft. Now we do have time for questions. So if you have any questions on this material, please either raise your hand on the screen so we can unmute you and you can ask a question, or go ahead and type it in and I'll read it back and answer it.
Well, it doesn't appear that we have any questions. Again, want to thank everybody for attending this session of ADCO University. These are scheduled on a 4 to 5 week basis, and we'll be sending out an invitation to the next webinar in about 4 weeks. Again, appreciate your participation, your attendance, and if you do have any questions, you can email them to us after the fact. Thank you again.